History as we know it, it's about to end. I don't mean the past itself, of course, but our entire relationship to it. Today, we're going to explore how artificial intelligence is on the verge of becoming the ultimate time machine, transforming the story of our planet from a book with missing pages into a film that we can watch right from the very beginning.
So let's just start with this massive question. What if you could forget piecing together fossils or trying to decipher ancient texts? Imagine actually witnessing the very first spark of life, or watching dinosaurs roam the planet, not as an animation, but as if you were right there. It sounds like total science fiction, doesn't it? Well, maybe not for much longer.
So to see how we could get there, we're going to break this down into 5 parts, basically following the incredible evolution of AI itself.
Okay, let's dive right in. The core idea here is that AI won't just help us study history, it's going to fundamentally change what history is. We are talking about a major shift away from educated guesswork to scientifically reproducible, super high-precision simulations. AI will take every single clue we have and fill in all the blanks with almost perfect accuracy. Now, this isn't going to happen overnight. It's really a journey through 3 distinct phases of AI, and each one is exponentially more powerful than the last. We'll start with the AI we have today, ANI. Then we'll jump to the very near future with AGI, and finally, we'll peek into the absolutely mind-bending potential of ASI. So phase 1 is actually happening right now. This is the era of artificial narrow intelligence, or ANI. And a great way to think of it is like having a team of hyper-focused digital archaeologists. And believe me, they are already completely changing the game. The key thing to understand about ANI is that its superpower is pattern recognition, but on a superhuman scale. It can just tear through mountains of data. We're talking satellite images, geological scans, ancient texts, and it can spot these tiny, hidden connections that a human researcher might spend an entire lifetime trying to find and still miss.
And get this. This isn't some theoretical, far-off future stuff. It is happening right now. AIs are using LiDAR data to literally peel back the jungle canopy and reveal entire lost Mayan cities. They're digitally unwrapping and reading burned ancient scrolls. The pace of discovery isn't just a little bit faster, it's on a whole other level. And this really puts into perspective the new timeline we're on. Research that would have taken generations of scholars is now getting done in just a few years, sometimes even months. You see, ANI isn't just another magnifying glass. It's more like an X-ray, sonar, and a supercomputer all rolled into one powerful package. Okay, next up, we step into phase 2 with the arrival of artificial general intelligence, or AGI. And this is where AI stops being just a tool and becomes a genuine collaborator. It's no longer just a digital archaeologist finding clues. Now, it's like a time-traveling detective that actually understands what all those clues mean. So what's the big difference? Well, unlike its specialized predecessor, AGI can think across completely different disciplines. It can pull together data from climatology, biology, and archaeology all at the same time. Its goal isn't just to find out what happened, but to finally solve the huge mysteries of why things happened on a planetary scale. And the dinosaur extinction is just a perfect example. An AI could take the asteroid impact data, combine it with models of volcanic activity and records of ocean chemistry, and then run a single, massive simulation. And what comes out the other end is the entire causal chain of events, from the initial impact to the final collapse of the whole ecosystem. The potential here is just staggering. AGI could show us precisely how a tiny change in ocean currents led to the fall of an entire empire. It could even predict the exact anatomy of a missing link fossil, and then tell geologists the specific rock layer in a particular valley where they're most likely to find it. Just incredible. All right, now we have to take a giant leap forward. Phase 3 takes us into the realm of artificial superintelligence, or ASI. And this is where AI moves beyond being a detective and becomes the omniscient narrator of our planet's entire story. This is where the line between history and reality just completely dissolves. An AI's goal wouldn't be to interpret the past, but to recreate it flawlessly, with the same fidelity as a live video feed, right down to the motion of individual atoms. Okay, so you're probably wondering,
How on earth is that even possible? Well, the core idea is a concept called quantum backtracing. The universe operates on fixed physical laws, right? So a powerful enough intelligence could, in theory, take the exact state of the planet today and calculate backwards to figure out the exact state of every single particle at any point in the past. It's like rewinding a movie, but for reality itself.
And the result of all that is the literal videoization of all of history. You could just ask it to show you the formation of the moon, or the moment the first fish crawled onto land, and it would just render the event for you. Not as an artist's best guess, but as a perfect, physically accurate recreation.
So let's pull all three of these stages together and really look at the profound transformation this means for how we understand our own past.
This table here really captures the entire journey perfectly. We go from ANI finding fragments of the past, to AGI understanding the context of how those fragments fit together, all the way to ASI establishing history as undeniable fact. And just look at that last row. That's us. Our role shifts from being the user of a tool to a research partner, and finally, to being a student, learning directly from an all-knowing narrator.
100%. With ASI, the certainty of historical events, like, say, the precise chemical steps that led to life on Earth, could actually approach 100%. The debates would just be over. The mystery would be solved.
So here's the crucial takeaway. We are witnessing the very beginning of a shift where history stops being an interpretive art based on whatever clues survived, and it becomes a computational science based on observable data. It becomes a matter of calculation, not interpretation. And that brings us to our final thought. When the entire 4.6 billion year past becomes an open library where every single event can be replayed and studied, what's the first question you would ask? What will we finally understand about ourselves when there are no more secrets left in our own history?